So often in programming is a need to repeat certain commands. So for example, let's say you wanted to count from the number 1 to 10. You might have to have a printf statement, printf 1, or it could be printf percentage %d, and then, or just maybe 1, or it could be, there could be a variable involved depending on your program. But then you want to print the next number, so you have printf2, then printf3, printf4, and depending on how the program operates, this repetition of code then can cause your program, or at least your code, to be very long. And this repetition can be actually of no point. And there's a way that we can then go and essentially wrap together the code that's going to be repeated, and in this way minimize the code that you've got to type. So less code means less memory that you're using in terms of the file that's being generated, and this could also mean less coding that has to go and be placed on, let's say, a small limited space computer like a microcontroller, which is something you'll be looking at probably in the near future. Okay, so for these repetitions of code, there's essentially two different scenarios that have to be taken into account. The first one we're going to be looking at is what's known as a for loop. The for loop, which is essentially spelled like that, this is for if you know how many times the commands have to be executed. So for example, if I say to you, enter a number between 0 and 100, and you want to count from 1 up to that number, then essentially it will, you'll know how many times to do that counting. It would be from that specific number that you started off and up to the number 100. So we're going to be looking at how to use that in this example. So in this specific example, we're going to be looking at a very similar scenario as what I just mentioned in terms of entering a number and you counting from that number to 100. Instead of, in this case, we're going to be counting from that number up to 100. Okay, so I'm going to have an int I, which is equal to 0. I is going to be a number we're going to be using in a for loop, and you'll see where it gets used. And I'm going to have a number input, which is equal to 0. Input is going to be the number that we're going to enter that the user's got to, or that the computer must count from. Okay, so first I'm going to have a printf statement. Okay, so enter a number to count from, or at least to count to 100. You might have a couple of new lines over there as well. Now, why is that all in highlighted in purple? Let's just see if we run it. Syntax error, return 0. There's something wrong with this printf statement. Let's see if we can quickly see what it might be. Printf, we open up the bracket over there. Apostrophe, enter num to be counted. Oh, I forgot a /n over there. So now, it's one of the ways that you can quickly check to see that something was wrong with the code. So again, just a typo of the letter N for the new line caused the whole line to go wrong. So now if we run it, it says at least enter a number to count to 100. Okay, so we need to have scanf statement. This is one that you should be very familiar with at the moment. We're going to have a %d, comma, ampersand input. Okay, so we enter in a number that we're going to want to count from to up to 100. So let's have a look at the for loop and how it looks like at the moment. So for I is equal to input, I is less than or equal to 100. I'll explain to you now in a minute in terms of what all these terms mean, and I plus plus. Okay, again we open up our brackets, we close our brackets over there. Okay, so according to this for loop, again this has all got to be in a bracket. You will see there's no semicolon represented over there either. What it means is that we set an initial value for I, which in this case is equal to input. We're then going to be having, that's going to be our initial condition over there. Then we're going to have I is less than or equal to 100. That's a condition that we're going to be checking if I is still valid. If this condition over here in the center is true, it means that the code over here in between the curly brackets will be executed. And then I plus plus. So we're going to be I plus plus is a way to increment the value of I. That's the same as saying I is equal to I plus 1. That will also work. So essentially, let's have a look. So the command we're going to have over here is printf %d, comma I. Okay, now I'm going to be placing a space after the %d. You'll see later in the output the reason for that. Okay, finally, I'm going to have a printf statement over here with 2 forward slashes ends. So I've got 2 new lines that gets printed afterwards. And again, that's just for layout purposes that I'm doing it. Okay, so let's have a look at running this, see what the output is, and then hopefully that will give you an explanation of the different inputs that we're looking at. So, okay, first we run it. It says, so it says syntax error. Can you see the reason for that, possibly? If you look over here, I forgot to place the semicolon. So for the printf statements, that's the reason it didn't run. Okay, enter a number to count from. So I'm going to say, let's say 90. Okay, and it exits with a code of 0. So you'll see what's happened is that when I inputted the value 90, what happened was the initial value of I was assigned the value of 90. Okay, then what would happen is that it would execute this command. So it was a printf statement and it prints the value of 90. Now it comes back, because I is the value of 90, right? It comes back to the beginning of this for loop and it says, okay, I'm going to ignore this first part of the statement over here. I'm going to be, because that I've already executed, that was done in the first time, I'm going to be looking at the second part of this statement. Is I less than or equal to 100? Well, I is equal to 90. But if that's the case, it's going to then increment the value of I. So I is equal to I plus 1. So remember with this, if we've got, we can have a statement in our code also like x is equal to x plus 1, as an example. If you have this type of code being run, actually let's make it using the variables we've got. Input is equal to input plus 1. So now, if we have to run this piece of code again, it would actually start counting from 9 to 1. Because what's going to happen is going to say, what's the value of input? Well, input is equal to 90. It's going to add 1 to that, which becomes 9 to 1. And that new value is then going to be placed into the variable input. So remember, left-hand side is equal to whatever calculation is done on the right-hand side. Okay, so as a matter of fact, let's run it and see how it goes with 90 again. See, so 91, 92, 93, 94, all the way up to 100. Okay, so like if we look at as we were going through this loop, it says I is equal to I plus 1. So in this case, it would say, okay, well, if that's the case, it's going to add the value of add 1 to the value of I. And it's going to print the next value. Now that you'll see the reason I place a space after the percentage D was again for layout purposes, so there's at least a space between the numbers. If I had to remove that space over there and run a program, you would realize all the numbers would be jammed up together and it would be difficult to actually see each individual number over there. So it's just as part of the layout process that makes it easy to read what's happening. Anyway, so this process will repeat. It will come to 92, 93, and every time the next number is being generated, it will output the value of I. Then eventually it will come to is that I then equals to 100. And it'll come over here and say, well, is I less than or equal to 100? Yes, it is. And it will print out the value of 100. We'll come back to the top of the loop over here, and it will say, okay, now if I is incremented by 1 and becomes 101, is I then less than or equal to 100? In this case, it will be false, and as soon as it becomes false, it exits this for loop and goes to execute the rest of the code. So these for loops are quite useful because it is often that there's a certain number of times that code needs to be executed. We might not know it in terms of actual values, but we might be able to associate it with some algorithm. The problem with these for loops is that you can have an issue. Like for example, if you have your equal sign over there just to be without the less than, you just say I is equal to 100. Now if you run it, it's going to go infinity amount of times. Okay, let's run it again. Let's put in 90. I'm just trying to be ready to press stop. And you'll see a whole bunch of 100s being printed over there. And the reason being for this is that it looks at the value of I, which is equal to 90. It's now telling you that it's not able to do a comparison over here, because remember, comparison with one equal sign doesn't work, and therefore it doesn't know what to do. It actually goes and just assigns I equal to 100 in a specific case. Okay, now we say it's a comparison. Let's make it two equal signs. How would that work? Okay, well, let's enter value 90. I'm getting ready to stop. Okay, didn't even have to stop. It just exit with a 0 because you input a value of 90 and that is assigned to I. I is then compared. Is I equal to 100 or 90? Well, 90 is not equal to 100, so therefore this statement is false, so it exits this for loop. If we had to run this again with 100, what would happen? Same thing would happen. So it's very critical to make sure that this is always less than sign. You don't have to have the equal sign over there. You can have it less than 100. So in this case, if we had to type in 90 again, it will go from 91 all the way up to 99. It won't include 100. Let's have a look at the larger numbers. So let's say, for example, 20. You'll see a whole string of numbers being generated over here, all the way up to 100, but starting off from the number 20 and then 21. Because it goes to, we've got the input plus 1 over there for the statement. It goes in from 21 all the way up to 100. Okay, so this is the basic format of your for loop. Keep in mind that we've got over here, we can assign we can do a calculation with a variable, and we can have that value assigned back into that variable. So it saves memory. So we don't have to have a new variable name that we have to now store in memory to save a certain expression if that specific variable input is not being used again. We had a look at the initial values that I would be assigned to for the for loop. We look at, and I mean, the reason we use an I over here for for loops is it's the general trend that programmers have used in the past, using the letters I, J, and K. But it's not necessary that you have to use them, yet that is some convention that has been used. The second sort of term that you've got in your for loop is a comparison term that gets used, that gets looked at, and in the third term over there is the one that gets taken into account in terms of how much it should add. So we could actually make this in terms of a plus 5. If we run it now, and we have to put in 20, for example. So what will happen is it will, from 21, it will add 5 to the number every time. You don't have to have it plus 1. You can just have plus 5. Like I mentioned over here, you could have I plus plus, and that will, if you had to type that in, that would be doing the same thing as I is equal to I plus 1. So it's a short convention that we use in for loops as well. So this is able to show us how to repeat the specific loop to accommodate for this and to allow us to repeat it a certain number of times, and we must know how many times this has to repeat. In other words, we need to have some condition over here that I will be compared to make sure that it doesn't go over that amount. If you do have something that is not valid, so if we had to type in the number 101, the program is going to then start also giving infinity numbers. No, it's not. Okay. Trying to sort of think of, okay, so let's say we make this I minus minus. That should work. So let's put in the number 20. And there we see it goes and starts subtracting 1 from 21 all the way down, even into negative numbers. And it will continue going on with this looping, because I will never reach a limit of 100. And with this infinity looping that's going to happen, you can actually cause that your computer can sort of start using too much memory. The operating system is going to shut down the CH program, and you're going to lose any code if you didn't save. So we want to prevent this from running on its own and out of control. So it's very critical to also just make sure that your commands are taken into account, so you don't have that type of scenario happening. Okay, so let's just run it again, see how that works. 20, and there we go, it's actually stopped, so it counts all the way from 21 up to 100.